Let's talk about power, which is the rate of using or doing energy. It tells us how fast energy is used or transferred. If two people do the same work, but one is faster, the person uses more power. Okay. Example is, a person climbs the stairs in 10 seconds. Another person does the same in 5 seconds. So both of them did the same work, but the second person used more power because it was faster. So the faster we do something, more power is needed. The formula for power is energy consumption or work over time. So power is equal to energy over time, or power equals work over time. The formula can be written like this: power is equal to energy over time, or sometimes written like this: power is equal to energy over time. Energy can be shown by different notations, or power is equal to work over time. As you know right now, work has the same unit with energy. Both of them has the energy of joules. Okay, so applying the SI units, we'll have the energy, the unit of energy is joule, the unit of time is second. So joule per second is the unit of power. Joule per second is also called watts. So power is measured in watts, and it is denoted by capital W. Let's do some examples. Power consumption of lamp is 8 watts. So 8 watt means 8 joules per second. Okay. If it is on for 2 hours a day, how much energy is used in kilowatt hour and joule in 1 month? Another thing to point out here is that, so based on this formula, if we apply the power in kilowatts, if we apply the power, so power is equal to energy over time. If we use the unit of kilowatts for power, and if we use the unit of hour for time, we can write E equals power times time, and then applying these formulas, energy will be kilowatt hour, kilowatt times hour, which means we usually read it kilowatt hour, kilowatt times hour. Okay, so kilowatt hour is another unit for energy, which is usually used for measuring electrical energy consumption, because it's large enough. Joule is a small unit, but kilowatt hour is much greater. So in this question and in this example, it says how much energy is used in kilowatt hour and joule in 1 month or 30 days. So what is the time? The time is 30 days of 2 hours is 60 hours. 60 hours. The power is given, which is 8 watts. So the energy consumption, or E, is asked. So if I want to use standard units, I need to turn this hour into seconds. So 60 times 3,600 seconds, or times 3,600. Or if I want to apply the units, I need to write here seconds per hour. Okay, let's drop the units here. So 60 times 3,600 will be 216,000. 216,000 seconds. This is the time given. This is the power. So what is E? E is equal to P times T, or power times time. So power is energy over time, and if we cross multiply here, energy will be power times time. Okay, so power is 8, and the time is 216,000 seconds. So multiplying this will give the energy in joules. So multiply by 8, we'll get 1,728,000. 1,728,000 joule. As you see, the unit of joule is a great, joule is a small unit. So the amount of energy used is 1,728,000 joule. Let's calculate it into another unit, which is this one, kilowatt hour. So let me draw a line to separate the solution. Now I apply another unit. Power is 8 watts. So what is 8 watts in terms of kilowatts? 8,000 watts. 8,000 of kilowatts. So 8,000 of kilowatts times hour. How many hours the lamp is on? 60 hours. So 60 hours. So multiplying these will be 0.48. 0 cancels one of the zeros here. This 0 cancels one of the zeros, so it will be 800th. 6 times 800th will be 4800th. So 4800th of kilowatt hour. So as you see, kilowatt hour is a much greater unit. The same energy consumption here is 0.48 kilowatt hour, but expressed in joule it is 1,728,000 joule. Okay, these are some real-life examples of power. These are activities in the first column, and then the energy used, and then time and power. Climbing stairs slowly. For example, if it takes 100 joules and if it takes 10 seconds to do it, energy divided by time will be power. So 10 watts of power is needed for such an activity. Climbing stairs quickly, the same amount of work is needed, but time is less time is needed because we're climbing quickly. Less time is used. So 100 divided by 5 will be 20. So that's why we say if we do something more quickly, the same amount of work is done, but more power is consumed because time is smaller. Time is in the denominator of the fraction. A light bulb is on. For example, it can use 60 watts of energy, 60 joule per second. So its power is 60 watts. Hair dryer, for example, uses much more energy, which is 1000 joule per second or 1000 watts. Okay, let's do another example. A pump is used to draw water from a well. If the water flows at a rate of 3 kilograms per second and the well is 20 meters deep, what is the power output of the pump? It says, as usual, take G to be 10 meters per square second. So what is the work done by the pump let me write the formula of the power. Power is work over time. What is the work done by the pump here? It overcomes gravitational potential energy because it brings up some distance. So when the pump brings up water from depth of the well to the surface area, to the ground, it overcomes some gravitational potential energy. Now, m over t is given to us. M over t is given to us, which is 3 kilogram per second. This is a rate of flow. This is flow rate of the pump. So instead of m over t, I replace 3. Instead of g, I replace 10, and height is given to be 20 meters. So multiplying these, I'll get 600. The unit is watt for sure. Or I can express it in terms of kilowatts. For example, 0.6 kilowatts. I divided this by 1000, I got 0.6 kilowatts. What is the power output of the pump? 0.6 kilowatts. But the pump uses electrical energy. At what rate pump is using electrical energy is another story. We're talking about the output power of the pump, because pump has an output and has an input. The input is electrical energy. The output is overcoming gravitational potential energy in here. Okay. Let's have a quick review on the materials we covered in this session. Potential energy is the stored energy waiting to be used. Types of potential energy are gravitational, elastic, and electrical. Power is how fast energy is used or consumed or produced. So power is energy over time, or rate of consumption of energy, or rate of producing energy. Watts is the unit of power. 1 watt is equal to 1 joule per second. Okay, it is enough for this third session, and bye bye for now.